Hello everyone, Mr. Burke here. So I hope everyone got the announcement about the changes that were taking place to the first test. I believe that in the future, as I work more closely with the department, that will not have to do this in between the time I release one and do another. So I will work to be more diligent on this in the future. But as promised, I am here to show the video of this, and I have uploaded a new practice test that you should see. And I hope that you'll find this helpful. So let me go ahead and share this, and I'm going to be doing this from my document camera and showing all the words to the questions here. Some of this is going to look familiar, and some of it's going to look different. Okay, so I want to make sure that I show all the work as appropriate. Okay, so first off, it says find the link, and this one says find the link S. So hopefully for this one, and I went over this in class, S is equal to R times theta. And just remember that this theta has to be in radians. So be aware of that computation. So if I plug information into there, I'm going to S is equal to 5 times pi over 4. And my final answer I can go ahead and write as 5 pi over 4 as being the exact, and that's going to be 5 pi over 4 centimeters, using the proper units to label your final answer. So this could be the final answer for question 1. So if you don't know this one, just make sure you have that on your formula sheet. Number 2, convert the angle in degrees to radians. As we've looked at before, we want to use the ratio of pi radians equals 180 degrees. And since this angle is in degrees, I'm going to put negative 105 here. And then calculate for x, which will determine the number of radians. It's going to be in 105 degrees. If I cross multiply, that's going to give me 180. And I'm going to lose the degree notation going forward here just to kind of simplify the math. 100x is going to equal negative 105 pi. I want to try to solve for x. I'm going to bring this answer up here without changing it. So I'm going to go ahead and divide by 180, get x by itself. Now, first off, the answer is going to have a negative. It's also going to have a pi. What we're trying to do from this point is to simplify 105 and 180. You may try reducing this by some of you may see that both reduced by 5. Others may see that both reduced by 3, but one thing they both definitely reduce by is going to be 15. So if I take let's say the fraction here, let's show this up here. If I take 105, ignoring the negatives, since I'm accounting for it here, in 180, and I divide both of these by 15, I'm going to get a result of 7 over 12. So this is going to be negative 7 over 12. So I'm going to have negative 7 pi over 12 in radians. So that's going to be negative 7 pi over 12 radians. And I hope everyone sees how that is done. Number 3, convert the angle in radians to degrees. By the way, I don't have all the point values on these yet, but I am going to be adding point values to these when it comes to actual test time. More work, the more point values these are going to have. So if I want to convert from degrees to radians, then I will take pi over 180 is equal to 4 pi over 5 times x. So when I cross multiply here, I'm going to get pi x is going to equal 180. I'll put that over 1 times 4 pi over 5. So now if I take 180 divided by 5, that's going to be 36. 36 times 4 is going to be 144. So we're going to get pi x is going to equal 144 pi. And then if I divide both sides by pi, I'm going to get x is equal to 144. And remember, we're looking for degrees, so that's going to be 144 degrees. And just to kind of follow up and label that in radians, I figure that's probably just to be as detailed as possible. Let's take a look at number 4, and this one's possibly going to be a little different. So let's bring this down. says a circle has a radius of 12 centimeters. Find the area of a sector. The circle formed by an angle of 60 degrees. Express your answer in terms of pi. So in this one here, we're given an angle of 60 degrees. Hopefully most people will remember that 60 degrees can also be written as pi over 3 radians, because the formula for the area of a sector of a circle is going to be 1/2 r squared theta. So we're going to put everything in there as appropriate. So it's going to be 1/2. The radius is going to be, one thing we should probably do with this also, draw a picture. Okay. And I'll make sure to, and when I put the actual question down, to indicate to draw a picture of what's being shown here. And it doesn't have to be perfect, but you should have this be 12 centimeters here. And I would go ahead and either put 60 degrees or I put pi over 3 radians. If you want to really impress me, put down the radians for that right away. And then I would have 1/2. This would be 12 squared times pi over 3. Okay, so now 12 squared, that's going to be 144. Okay, so 1/2 of 144 times pi over 3. Okay, so a third, if I take this, a third of one, so you could do the math on this in your calculator if you want. But a third of 144 is going to be equal to 48, and then half of 48 is going to be 24. So your final answer to this is going to be equal to 24 pi, and this is going to be centimeters squared. So just be mindful to also include the units in your final answer as well, because 24 pi centimeters squared, and it mentions here express your answer in terms of pi. So please be sure to do that. Okay. So I always want to say any questions I can do in class, and I realize I'm like not in class, so it doesn't really benefit. However, if you do have questions about what I'm going over, please don't hesitate to email me, and I'll try to provide some further clarification on these if possible. But I hope what I provide here in my explanation and drawing everything out will be beneficial for you to do on the exam. So two sides of a right triangle ABC, where C is the right angle, are given. Find the indicated trigonometric functions and of the given angles. Give exact answers with rational denominators. Very important. Find the sine of A where A is equal to 7 and B is equal to 2. Okay, now I believe we've done this in class yesterday, but just remember a thing or two about how triangles are drawn. So when I draw the triangles, they may not necessarily be to scale, but I always kind of draw them like I would draw triangles in the first quadrant. And they want I'm usually going to try to refer to the angle in the lower left corner as like my reference angle. So this is angle A. This is side A. Remember that we're going to have the angles always opposite. The angles in large letters opposite to the side in small letters. It mentions here C is the right angle. So I'm going to put that here. And of course, across from the right angle is going to be the hypotenuse. That's going to be a little c. Up here, I probably drew this a little close here. That's angle B. This is going to be side B here. So we want to get a good picture of what the triangle is. Let's also take a look at the information that's provided. It says that A is equal to 7, and it says that B is equal to 2. All right, so we have this information here. It asks us for the sine of A. So if it's asking for the sine of A, it wants the ratio of the opposite over the hypotenuse. So I'm going to write this in red here to kind of distinguish the dimensions of the triangle and the layout of the triangle versus the trigonometric qualities of the triangle. So as I've mentioned in class here, we're going to identify the 5 pieces of the triangle as I've discussed before: right angle, hypotenuse, the reference angle that they give in the problem, the adjacent side. Fortunately, the adjacent also turns out to be A. Sorry, not the adjacent, the opposite side. So yeah, so we're gonna have a side for opposite. This is adjacent. And then finally, the adjacent side is the side B. So the reason I use a different color is I don't want you to confuse the A value, which is given in the triangle, versus the A for the adjacent, which is part of the trig identity, in terms of how we label things in relation to trigonometry for the triangle. So because we're asked to find the value of sine A, we know what the opposite is already. That's 7. But we don't know what the hypotenuse is. So what we need to do next is we need to to take a look at the sides a squared plus b squared equals c squared and apply the Pythagorean theorem. So this is going to be a squared plus b squared equals c squared. This is going to be 7 squared plus 2 squared equals, that's going to be c squared. We don't know what that is yet, but we're going to find it out. This is going to be 49 plus 4 equals c squared. This will be 53 equals c squared. I'm going to bring this up here. You don't have to write this twice. I choose to because I'm showing notes on it. And when I do this work here, I don't want to lose this step by being absorbed by taking the square root of both sides. So then c is going to equal the square root of 53. So now I know what the hypotenuse is. That's going to be equal to the square root of 53. So when I find the sine of a, I'm going to say here that the sine of a is going to equal the opposite, which is equal to 7 over square root of 53. However, remember, it says give exact answers with rational denominators. So don't use a calculator for this, and we have to make sure that we rationalize the denominator as I taught in class. So in order to do that, I'm going to multiply the top and bottom by 53, is the root of 53. And for our final answer, that's going to give us the sine of a could equal 7 over the square root of 53 divided by 53. And that is going to be an exact answer. So when they give you directions about finding an exact answer with rational denominators, this is what we are looking at. All right, so that's question 5 done. Question 6 may look a little familiar, but we're asked to identify a few other things. So in this question, where it says use the definition of identities to find the exact value of the indicated trigonometric functions, and make sure to add that mass there, of the acute angle theta. Okay, so it mentions that it's an acute angle theta, which means that everything is going to be positive or less than 90 degrees. So our cotangent cosecant is going to be positive as well. So let's say we have cosine is equal to 5 over 13. It says find the cotangent of theta and the cosecant of theta. So if you're given the cosine, remember the relationship of the cosine of theta, this is equal to the adjacent over the hypotenuse. So what that's going to tell me is that in a right triangle, we can let the adjacent be equal to 5 and the hypotenuse is equal to 13. So we're going to go ahead and draw a picture of a triangle containing those dimensions. So here's my adjacent, that's going to equal 5. Here's my hypotenuse, is going to equal 13. We're going to go ahead and label this theta because we want this to be the adjacent side, so our theta is going to be here. What we don't know is what the opposite is. Now, for those that may be familiar with the Pythagorean triples, if you know this is 12 and you don't show me the work for the Pythagorean theorem, I'm going to be okay with that. For a question like above, that you have to apply the Pythagorean theorem. But in the construction of this is, I want to know that you can look at this, identify these two sides, go right to this, and then, hopefully get 12 for this. But if you don't know that's 12, then we're going to have to use like what? The adjacent squared plus the opposite squared equals the hypotenuse squared. So that's going to be 5 squared. Now be careful. If you need to use something else there, go ahead because that can be confused with 0, of course. That's going to equal 13 squared. This will give me 25 plus 0 squared is equal to 169. If I subtract 25, I get 0 squared is equal to 144. And now I'm writing twice again, so when I go to take the square root of both sides, the opposite side is going to equal 12. As I mentioned, 5, 12, 13 is a pretty famous Pythagorean triple. Now I know what the opposite side is. Which two trig functions are we asked to find? We're asked to find the cotangent of theta and the cosecant of theta. So the cotangent of theta, that is going to equal the adjacent over the opposite. But remember that tangent is opposite over adjacent. So cotangent is going to be the reciprocal of that, which is adjacent over opposite. And the cosecant of theta. Well, that's the reciprocal of that is the sine. And since the sine of theta is equal to the opposite of the hypotenuse, the reciprocal, the cosecant, going to be equal to the hypotenuse over the opposite. So really important that for both of these, we absolutely need the opposite. We can't get away without finding the opposite for both of these. And we can go ahead and put these values in. This is going to be 5 over 12. And this value here is going to be 13 over 12. And we'll have our answers. Now, if you can't put all of these in the space provided, please be sure to box off your final work containing the answers so that it makes it easier for me to find the results we're looking for. Okay. Let's go on to number 7 here. If, let's say, for example, you kind of just recognize this and just tell me that the answer is 1, okay? I need some more justification than that, okay? So what are kinds of things I'd be looking in a question like this or similar to a question like this? So the first thing I'd be looking for is an understanding when we're working with complementary angles. Some things that would be helpful to state is that you know that the sine squared theta plus the cosine squared theta is equal to 1. One identity, and you don't have to justify why this is the case. You could also say, for example, that you know that the sine of 65 degrees is equal to the cosine of 25 degrees. Okay. You can also finally say that the cosine of 65 degrees is equal to the sine of 25 degrees. With these facts in mind, I can make the following substitutions in the problem. See, I want to have this be sine squared if possible. So we have the sine of 65 here. I noted the sine of 65 is equal to the cosine of 25. So I'm going to go ahead and I'm going to replace cosine of 25 with the sine of 65. So I'm going to have the sine of 65 degrees times the sine 65 degrees. I can make that substitution into that there because of what I have here. Plus, I can roll this off a little bit. I know that the sine of 25 is equal to cosine of 65. So I'm going to write this as the cosine of 65 times this the cosine 65. What's important about that here is that all these angles here have got to be the same. We have to be talking about the same angle across the board here. From here, if I have the sine of 65 times the sine of 65, this is the sine squared of 65. This is going to be the cosine squared of 65. And from that, based on that, you can say with theta equaling 65 degrees, for all this, you can say this all equals 1. And that's going to be the work you need to show to get your answer to this problem here. That's number 7. Let's take a look at number 8. So this is just an application question, and you're just kind of putting everything into the calculator on this one. So, and by the way, there will be, if you look at the solution to question 8, the correct solution is going to be in the back of the answer sheet. So this one will work. So in the problem, they give you everything. They tell you that G is going to be equal to 32 feet per second squared, 32 being the key number we're looking at here. It also is going to tell you that the value of A is going to be equal to 14, and that theta is going to equal 45. So we're going to take this formula as we have it here, and it's going to be T is equal to the square root of 2 times 14 divided by G being 32, excuse me, 32 times sine of 45 times the cosine of 45. And this is all like under like one large radical. Okay. Now, if you have a calculator that's sophisticated enough, you can just kind of put all this in it and generate an answer. But where are there some areas you could simplify this a bit? Okay. Well, be sure again to include your radical. I can say 2 times 14, that's going to equal 28. We have 32, and this is going to be times, well, sine of 45 is going to be radical 2 over 2. Cosine of 45 is going to be radical 2 over 2. Well, we have 28 on top still. That's not going to be further simplified anymore. Then you have the square root of 2 over 2 times the square root of 2 over 2. This is 2 over 4, which is going to be, if I can just kind of simplify this a little bit, 32 times 1/2. So it's going to be square root of 28 over 16. Now, again, if you have a calculator that can like do this in one fell swoop, go ahead and do that. If you don't have a sophisticated calculator, you can do some simplification a little bit and do the square root of 20 over 16. And for this one, this one we should get an answer to the nearest tenth of a second, or this is going to be equal to 1.3 seconds for pushing. Okay, let's go and take a look at number 9 then. A point on the terminal side of angle theta is given. Find the exact value of the indicated trigonometric function. And probably for this, we're going to go ahead and ask you to, let me highlight this here and to include a picture of what this is going to look like. So I'm going to just kind of this does not have to be a great picture, but you should have some kind of a picture. So we kind of know what's going on. Remember, the initial angle is always going to be from between the fourth and fifth quadrant here on the x-axis. And if we're looking at the point -5, -12, it's going to be something like this, where we go down a ways, like this, -5, -12. And we see, first off, we're ending up in quadrant 3. And for this, it wants us to find the cotangent of theta and then the secant of theta. So recall when we're looking at this here, just from a geometric standpoint, this is going to be a length of 5, this is going to be a length of 12, this is going to generate a value of 13. So just to kind of bear that in mind, that's something we looked at before. If you know that, and you want to put that without doing the Pythagorean theorem, you're absolutely welcome to go and put that in if you know that relationship. Or if you're given another similar triangle that is a common Pythagorean triple, for me, it will not be necessary to show the work of doing the Pythagorean theorem to get it, but you should be ready to use the Pythagorean theorem if you need to. So this is going to be 13. So, well, one thing we can say with regard to this is, in this situation, you should know that the sine of t, that's going to equal the y value. So the sine of t is going to be -12. Cosine of t, that is going to equal, sorry, sine of t for this one, excuse me, it's not unit circle. The sine of t is going to be -12, and over the hypotenuse, which is going to be 13. The cosine of t is going to be -5 over 13. And then what else do we have here? We have the tangent, which is going to be let me write the tangent over here, actually. Tangent is going to be equal to the sine over the cosine. So this would be -12 over 13 divided by -5 over 13. If I work that out, that's going to be equal to -12 over 13 times 13 over -5. So the tangent is going to be 12 over 5. So why is it helpful to have these relationships? Because if you know your sine, your cosine, and your tangent from this, you should be able to get your cotangent and your secant based on the reciprocals. If you know that the tangent is 12 over 5, you should probably know, is what's asked for, and I'll put that in red to highlight this, the cotangent is of theta. And by the way, they use theta and I've been using t. So let me go ahead and correct that. If the tangent of theta is equal to 12 over 5, the cotangent of theta is going to be equal to 5 over 12. We've discussed these relationships a lot in class. And then your secant of theta, the secant of theta is the reciprocal of the cosine. So if the cosine is -5 over 13, then I can write the secant as -13 over 5. And there are your answers for question number 9. Let's take a look at number 10. It says, use the fact that trigonometric functions are periodic to find the exact values of the expression. Do not use a calculator. Draw a picture as appropriate for full credit. So those directions I added. So if I want the sine of 855, you recall that I used I started this new technique of using two circles in class. We're going to find this angle of 855. And we have a little calculations going on the side. So first we go around once. So this is going to be 855 minus 360. I want to say, hang on. Generally speaking, I trust my math, but I think this is going to be 495. Hang on. 855, 60. Yes, 495. So, which means I'm going to need to go around one more time. Okay, so minus 360. That's going to be 135. So at this point, I want to draw the angle 135. Okay, so I go here. Here's my angle. And what I'm going to realize here is that this angle that remains here, that's going to be 135 degrees. All right. So I can say essentially that the sine of 855 degrees is equal to the sine of 135 degrees because they're the same angle essentially in here because of the periodic nature of the sine function. However, we also need to consider how far this angle is away from the x-axis because we're going to need to come up with the reference angle in the first quadrant over here. So if this is 135 degrees, that means that the measure of this angle here, that's going to be 45 degrees. So when I bring that 45-degree angle over here, and what I want to find is the sine of 45 degrees. And hopefully most people know that the sine of 45 is equal to radical 2 over 2. Because what that's going to mean is, if the sine of 45 is radical 2 over 2, the sine of 135 is going to be equal to radical 2 over 2. And the sine of E55 is also going to equal radical 2 over 2. Now, the last thing we have to consider is, what quadrant is this angle in, 855? Well, this angle is in the second quadrant, and that's going to help us determine the sign of this. The sign of the sign, if you will. Like if it's a positive or if it's negative. And remember that in the second quadrant, the sign is always going to be positive. So the final answer to this is going to remain positive 2 over 2. Okay. I pause because I'm used to doing this for class and questions and whatnot. Okay. Let's go ahead and take a look at number 11. We have 5 questions to go here. Again, like I said, once we get to the test, we'll assign point values, but I want to make sure to get this video up as soon as I can. It says the point P in the unit circle that corresponds to a real number T is given. Find the indicated trigonometric functions and find tangent of T. All right, so remember that sine of T, that's equal to the Y value. The cosine of T is equal to the X value. And then the tangent of T, that's equal to Y over X. So when you're doing a question like this, you want to be able to understand that, and that makes this a very quick question if you've got that done. All right, so if you want to find tangent of T, that's going to equal radical 21 over 5 divided by 2 over 5. So I multiply this out, it's going to be radical 21 over 5 times 5 over 2. 5's reduce each other, giving me radical 21 over 2. And that's going to be my final answer for the tangent of T, radical 21 over 2. My final answer for question 11. So that's hopefully, if you can recall that or write that down in your cheat sheet and grab that bit of information, that makes for a quick question. So some of the questions are going to be quick. Okay. That means questions won't be worth as much, but that's okay. So hopefully they're easier than some of the questions we encountered. I left the room on this question because the question we have on the next page, which I expanded upon a little bit to make sure you have enough room to show your work. So in this question, it says, find the exact value of the expression. Do not use a calculator. Draw a picture as appropriate. We want the tangent of 15 over 4. Okay, so and then the cosine of 15 over 4. What I'd like to try to do is identify what this angle of 15 pi over 4 is, so that we can find the appropriate value of this and then the sign as well. So I'm going to draw two pictures here. Now, if I want 15 pi over 4, 15 divided by 4, that's going to give me 3.75. So we're talking not quite 4 pi, just a little under that. So let's see if we count this off a little bit. So I'm going to go around this angle a little bit here. That's going to be 1 pi radians, 2 pi radians, 3 pi radians. Now, if I go from here to here, that's going to be 4 pi. That's too far. So 3 pi radians, 3.5 pi radians. So between 3.5 and 4 is 3.75. So we're going to have this angle right here is what we're talking about. So this angle we have written here is the angle 15 pi over 4 radians. That's this angle right here. What I'm really interested in to know is, so this is an angle in the fourth quadrant. I want to know how far it is away from the x-axis. And that's going to be, so you can write this, since we're talking radians, you can write it as 45 degrees, so you can write it as pi over 4 radians, which makes sense because 15 pi over 4 plus 1 pi over 4 will give you 16 pi over 4. So I want over here, looking at my reference angle, if I have this as pi over 4 degrees, what do I want? I want to know what the tangent of pi over 4 is, and then I want to know what the cosine of pi over 4 is. And hopefully everyone knows that the tangent of pi over 4 is equal to 1, and the cosine of pi over 4 is equal to radical 2 over 2. Now, when we're doing this here, we are considering just the value of this. So if I know that the tangent of pi over 4 is 1, I'm going to know that the tangent of 15 pi over 4 is 1. Now, we're not addressing its positive or negative yet. Okay, we'll talk about that. So this is going to be 1, and then the minus, this will be radical 2 over 2. I'm going to put this in parentheses because I want to talk about the sign now. In the fourth quadrant, we hopefully know that tangent is going to be negative. And if we do, we add the negative there. In the fourth quadrant, we should also know that cosine is going to be positive, so we leave this as a positive. So now that we address both the value of each of these trig functions as well as the sign of each of the values of the trig functions, we can now work with this to write this as negative 1 minus radical 2 over 2. But usually this is not considered the proper form that we want to put this in. So what we can do is we can write this as 2 over 2 minus radical 2 over 2. And since we now come to nowadays, I can go and write this as negative 2 minus radical 2 over 2. And that would be my final answer for question 12. Okay, let's take a look at question 13. So one of the things I find helpful in a question like 13 is to include a couple transformations and then have you map these out. Okay, and I decided to include a few maps to use the graph, like the original functions to this. So it says use the first graph to plot the parent function and then the remaining graphs to plot the solution. So what I might do first, for example, is I might just go ahead and plot the cosine of x. So my first graph here is going to be y equals cosine x. And how is that going to graph? That's going to graph from 1 down to negative 1. It's 0 here, and then 1 again. So it's going to graph something like this. Now, I'm not looking for perfection on this here, but these are curved. I know if you kind of plot points here, 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 you could almost draw them like an absolute value function. Don't do that for me, please. These are curved functions. Give them a little flavor. So next what I'm going to do for the next graph down here is I'm going to graph this as y equals 2 cosine x. And how is that going to change things? That means I'm going to plot here at 2, 0, negative 2, 0, and then 2. So it's going to allow me just kind of expand this a little bit so I can make it a little bigger. And then when I have the third graph down here, I could then plot the graph of y equals 2 cosine x plus 3, which is going to involve a vertical shift where everything is going to go up 3. So the 2 is going to go up to 5. The 0 is going to go up to 3. The -2 is going to go up to 1. The 0 is going to go up to 3. And then the 2 is going to go up to 5 again. And now, mind you, you could graph this like an absolute value function, but it still is a cosine function curve, so it should still look something like this. So we're going to be looking for some type of solution. And when you get the solution, please box this so that you can indicate your work as appropriate. Okay. So that's why we have 3 graphs here to kind of let you graph the parent function, let you carry out the first step. This is the cosine of x. And then this will be y equals 2 cosine of x plus 3. Okay. 2 more questions. And the 2 questions here, I think we did 1 question with angle of elevation, angle of depression. I'm going to show you how this works, and definitely a picture is what you're going to want to show for this one. So pay close attention to how we get away with this. From the edge of 1,000-foot cliff, the angles of depression for 2 cars in the valley below are 21 degrees and 28 degrees. How far apart are the cars? Okay. I'll probably provide more work than what I currently have here, but let's draw the picture. Now, when we talk about an angle of depression, we're talking about if we have this kind of like horizontal line of vision, that's the same as this here. We're talking about how far someone's going to have to look down at 2 vehicles. So I'm going to draw, let's draw one of these in green. So here's going to be 1 car, and then we're going to draw another one of these in purple. It's going to be the 2nd car. So I'm going to say that this first angle here from the horizontal line of sight, that this is going to be 21 degrees. And I'm going to say that the second angle from the line of sight is going to be equal to 28 degrees. So that's the entire angle here. Is going to be 28 degrees. All right. So it asks us how far apart the cars are. That's this distance here is what we're looking at. Okay. So what we're going to do in order to do this is we're going to have to do labeling of a few things. Okay. So in this problem here, here's our right angle. And actually, you're going to notice that we're going to have 2 different hypotenuse parts here. So I'm going to go ahead and label this hypotenuse in purple here. I'm going to label this hypotenuse in green. Okay, so I know I'm working 2 different ones. What's going to be the same for these is I have this height of 1,000 feet. And what you notice here is that for the little hypotenuse, I've got this value of the adjacent here in purple. Okay. Oh, sorry, they have 100 for this here. I should have 1,000 feet. Okay. For the larger triangle formed by the longer hypotenuse, I have this longer adjacent side. And what we're going to do is we're going to find the shorter adjacent side. We're going to find the longer adjacent side. And then what we'll do is we're going to take the difference. And the difference is going to leave us with that x value. So if this is like, if this is 500 feet and this is 700 feet, if this is 500, this whole thing is 700. That means they're 200 feet apart, if that makes sense. So what we want to do now is we want to try to figure out what is the trig function that's going to help us best with this. One thing that's going to be helpful too, if you see we have these angles of depression here. This is a 28-degree angle. If this angle from here to here is 28 degrees, this angle here is 28 degrees as well. And that's the angle, that's where we really want this, because that's going to help us the most in terms of the trig identity. If this angle here from the line of the horizontal line of sight is 21 degrees with here, that means this angle here is 21 degrees also. So this 21 degrees and this 28 degrees up here, these are considered angles of depression. The angles as we have them here, if this was like the people driving the cars and looking up to see this guy on top of the cliff that's 1,000 feet high, these would constitute angles of elevation. But these are going to be the same. It's like You recall learning back in high school about lines that are parallel. If they're cut by a transversal, they're going to produce alternate interior angles that are going to be congruent to each other. So that's the principle we're using here. So what we're going to do, we're going to take a look at what we know and then what we need. Okay. So first off, we have this. We have the hypotenuse. It looks like we know the reference angle. We know the opposite. So we know the opposite. We don't know the adjacent. We don't know the hypotenuse either, but really we don't need to. Okay. We know the adjacent. We don't need the opposite. So what do we know? So I'm going to divide this work up into two parts here. And I'm going to take this work beyond here. So let's see. In so what we know. And I got to divvy this up here. What we know. Well, for the smaller triangle, I know that theta is equal to 28. I know that the opposite side, yeah, this is going to, so for all of these, this is the opposite side. That's one thing I didn't acknowledge. So here's the reference angle, here's the reference angle. This is the opposite side. So the opposite side is going to be equal to 1,000. What I don't know is the adjacent, and this is what I'm interested to know. Now, by adjacent, we're talking about the adjacent like here in purple, okay? Second problem is we know that theta is going to equal 21. We also know the opposite side is going to equal 1,000. That's not going to change. But we don't know this adjacent either, okay? And what's going to happen is we're going to take this larger adjacent side, which is going to be larger, subtract the smaller adjacent side, and then we're going to have our answer. So we're going to find these. So this is, by the way, for this part here, this line of information, this is what we need. So then we ask ourselves, what trig function gives us opposite and adjacent? Of the three, like sine, cosine, tangent, which gives us that? It's going to be tangent. So what I'm going to say here is we're going to have the tangent of theta is going to equal the opposite over the adjacent. And then over here, we're going to have the tan of theta equal the opposite over adjacent. And from here, we can go ahead and solve the adjacent side. So when we do this here, we're going to have the, solving this, the tan of 28 degrees equals 1,000 over the adjacent. Over here, we're going to have the tan of 21 degrees equals 1,000 over the adjacent. So in other words, all this work is going to be the same. And I'm going to just kind of go on to solve each of these. When I cross multiply, I'm going to get 1. So let me put this over 1. Let me put this over 1. This is going to give me 1,000 equals, sorry, this is the tangent here. The tan of 28 times a. So I'm going to take 1,000 divided by the tan of 28. Now, some of you may try to find what the tan of 28 is first. You can do so, that's fine. I'm going to do this on my calculator quickly. And the distance on, I think I did this correctly, is going to be 1,000 for the solution for A. It's going to equal 1,800. And wants this to the nearest tenth of a foot. My goodness. 1,880.73. So 1,880.73 is what I get there. I put it to the nearest hundredth just in case rounding is a consideration because it wants the nearest tenth of a foot. Let's try this one now. This is going to give me 1,000 equals the tan of 21 times a, which means I'm going to divide both sides with the tangent of 21. So let's see what I get here. So 1,000 divided by and for this one, I go ahead and I'm going to get for A, that's going to equal 2605.09 feet. So that the distance in purple is going to be 1880.73 feet. The distance in green here, this whole thing is 2605.09 feet. In order to get this distance, I take the longer distance and subtract this portion to be left with this. So I'm going to have for my final answer 2605.09 minus 1880.73. Just put the rounded values of these in. So 2605.09 minus 1880.73. That's going to equal 724.4 for I want to make sure this is correct. Yeah, feet. So the answer to this is going to be 724.4. And in fact, yes, that's what's the answer of the back page. So that turns out to be correct. So this question is going to be worth 10 points. You can see the amount of work associated with this question, but I hope that drawing the picture out, looking at the angle of elevation and the angle of depression, and using different colors, both for the drawing and the calculations, helps to simplify and reinforce your understanding of this problem. Okay. Last question, and this is a much shorter one. Hopefully everyone should be familiar with this. We've done a number of these in class. It says, find the exact value of the indicated trigonometric function of theta, where you have the cotangent of theta equals -5/2, and the cosine of theta is less than 0. So first thing we should try to do is identify what quadrant this is going to be in. So if I were to do that, we go and do that off to the side a little bit here. I know that if tangent, so tangent is positive here and here. So tangent here is positive. We have the cotangent negative here, cotangent negative here. Those are the two quadrants of cotangent negative n. Here it also says the cosine is less than 0. So the cosine is also less than 0. Remember that in this quadrant, so no, we're not looking at these two, just these. Cosine is positive in this quadrant. And because the cosine is negative in this quadrant, we can go ahead and look at this then. So we're gonna look at this in the second quadrant. So if we have the cotangent of theta equal -5/2, let's go ahead. Remember, what's the cotangent of theta equal to? So the cotangent of theta, this is equal to the adjacent over the opposite. Okay, so what we're looking at in the second quadrant is we're looking at a triangle that goes back like 5 this way and then up 2 this way. So we're looking at a situation something like this, where the cotangent is going to be adjacent. This is going to be a distance of 5. This is going to be up 2 because it's adjacent over opposite. And we need to find what the hypotenuse is going to be here. Okay, so let's go ahead and calculate this out. So we're going to have a squared plus b squared equals c squared. We don't know what the hypotenuse is. Let's go ahead and call this 5 squared plus 2 squared equals c squared. That's going to be 25 plus 4 equals c squared. And it's going to be 29 is equal to c squared. And we'll come back to that work in a second. If I take the square root of both sides, c is going to equal the square root of 29. So now I identify the hypotenuse as the square root of 29. Now that I identify the hypotenuse, it asks for the cosecant of theta. So if you can remember that the sine of theta is equal to the opposite over the hypotenuse, you recall based on the work we did in class before that the cosecant of theta is going to equal the hypotenuse over the opposite. And since we have one more thing to consider too, if the sine is positive in quadrant 2, which it is, the cosecant is also going to be positive. So just wanted to mention that little fact. So we have the hypotenuse equal to radical 29. We have the opposite equal to 2. So the cosecant of theta is going to equal radical 29 over 2, which I believe is a result that's going to be on the answer sheet in the back. So I hope that everyone found this review to be helpful. I'm gonna stop sharing. I included this updated version for you to print out for yourself and to consider as well. Um, if you have any questions about what's in the thing, please ask. I may not get to them till later tomorrow if you send them my way later then. But I do look forward to hearing for your questions, and I hope you have a good day and a good rest of your weekend. Thank you.